How's everyone doing? Great? One more talk, and then we can have a drink, right? All right, thank you all for joining. We're going to talk about a platform we have been working on for a year now. And my name is Kamal, and let's just introduce ourselves.
So I'm Prashant. I work as a data engineer at Salesforce.com. Before Salesforce, I worked at Lookout as a data engineer. And prior to Lookout, I spent some time at Cloudera and Yahoo. So been working with the Hadoop ecosystem for a while now.
Yep, thanks, Prashant. And I'm Kamal. I run the data engineering for product data science for Salesforce. And our main charter is to help data science team and help our product managers and product teams achieve higher growth, accelerate growth of our products. How many of you are familiar with Salesforce? Great, everybody is. That's what I was telling him. We work for a popular company, right? So just a little bit about the use case. As you know, Salesforce offers customer success platform on the cloud. It has different clouds. Sales Cloud and Service Cloud are two popular offerings, and there are several other offerings as well. Everything is delivered through a cloud. And essentially, any company out there can use Salesforce offerings to connect with their customers, to give better service to their customers. And it has a model that is very subscription-like, just like Netflix. You pay by the month and by the number of users. So the use case we have is, you see that cloud there, and all of those little circles is our business units, each of our clouds, Service Cloud, Sales Cloud, et cetera. And the group that we service to is the product R&D group. And some of the main questions they would have is, how is my product doing? Are we seeing the adoption the way we would like to see? Which features of my product are doing well? Which ones are not doing well? How are people churning? What is the profile of the people who is churning and stuff like that? Back in the day when we had, before Hadoop, all of the data was stored in the cloud as objects, Salesforce objects, and those objects would be ingested into warehouses for analysis and dashboarding. As you know, things don't scale beyond a point, and Salesforce is growing at a very fast pace and has a large number of customers and organizations using it. We have over 200,000 companies using Salesforce, and we have like billions of devices connected to our ecosystem. At that scale, typical data warehouses do not scale. So we kind of start with our big data journey. Now, I want to show you a couple of questions that people typically ask when they're looking at their product, right? Some of the questions are straightforward in the sense, what is my MAU? What is my MAU for a product or a feature or any granular level? And how are my customers, what is the profile of my typical customer? From which region, which type of company, and so on and so forth. That's the top left side of things, typical graphs, traditional analytics, advanced analytics, those kind of things. The second set of use cases are more interesting. These are, a product manager would like to know how are users traversing his product. If you take Sales Cloud, for example, there is something called opportunity, there's something called task, there's something called calendar. Are my customers traversing more from this place to create an opportunity? A typical question could be something like, what is the most popular way to create an opportunity in Sales Cloud? You can do it from several places. Or what is the most popular way so that they can focus on that aspect? And as we plan or release this out, they focus their energies on those features so that customers have the most experience. So those are two sets of questions that we try to answer through our system. And when we looked at this use case, we wanted to implement a platform so that we can abstract a lot of underlying lower level details and give our customers, that is our product managers and execs, the power of asking these questions in that way, like what is the most popular way to create an opportunity, and we would create they can see all of the different graphs and slice and dice them. Now, if you see the flow, Salesforce is a cloud product. It's deployed in several hundred servers or thousands of servers in different clusters all over the world. We bring data from the various clusters into our ecosystem through various data ingestion technologies. Some of it is using Salesforce API, if it is the objects, and some of it is using Kafka for log lines, bringing them in near real time. And once we have all of this data, that's where this platform really comes into shape to curate the data, to do all kinds of data normalization, data harmonization, and create these data products, which are dashboards, which are advanced analytics, and this data also feeds into our data science to do predictive analytics on top of this data. Now, just a call out on the dashboards, we use our homegrown product. It's available as an offering for Salesforce as well. It's called Salesforce Analytics Cloud. It's a in-memory search-based analytics platform. If you haven't seen it, I strongly recommend to check it out. And we use that for our visualization. Now, let's talk a few minutes about how it all started. So a few years ago, when Hadoop was made available for internal groups, as a product, we have been having it for a long time. For internally, when we want to do analytics on Hadoop, we got this nice big cluster, and the group over there, they stood up the cluster, and great. And several people started bringing in the data that they like, right? Like in any other shops, they all started bringing in the data that they wanted to use to solve their problem. And eventually, pretty soon, you realize that you have these different groups bringing in sometimes the same data and running very similar processes and creating similar data insights. Now, as you can see, beyond the obvious problems of data duplication and I/O and all of that stuff, the main problem is data quality of the metrics. We may be having different metrics that were calculated slightly differently. They would mean very different things. There's not much governance, and so on and so forth. That was a big, painful problem for us. And we being the product data science team, we service various products, and different groups would be giving a number that may not be looking at all of the corner cases, and those numbers would look different, and a lot of times we end up with why are these numbers quite different than the others. And that's the problem we try to solve. Any questions so far on the use case itself or on Salesforce? Cool. Now, as we build the platform, we'll talk about the details of the platform in a minute, but as we build the platform, we didn't start out like, okay, we want to accomplish all of this in one go, right? We started in many different steps. The first few steps that we made sure was the code reusability and making sure that we have a way to organize our logic along with our data and provide a declarative way of applying logic. What do we mean by that? So we wanted to use an internal notion of how do you measure things and how do you objectify it. For example, I was giving the sales code example, and traversing through an opportunity is something that product managers and execs would totally understand, right? But under the covers, within log lines, it's probably a map job, map-only job, applying a filter on the map reduce. We kind of made that transition to use a declarative way of specifying what is the question, and internally we would run the actual jobs with the logic. And once we started doing that, then we had several data sets, and as we reuse the code, we can also reuse the data sets. We have the same metrics, we didn't have to calculate multiple times, and then we kind of came up with the notion of data lake. And as we were building the data lake, all of the typical issues or problems of data lake come into existence, right? What what is the, how do you profile the data? Can you ensure quality of it? The SLAs, and what all data do you have, right? And all of the following steps followed from data lake to we started building a data dictionary with the data sets we have and the columns we have and the description. The next level, we also added the logic we use to create those data sets and metrics. And following that was self-service. So typically when we had this platform, it still needed an engineer to apply these definitions and still run the processes. Then we created a web app, and the web app was mainly to, in a self-service way, anyone in the company can, or mostly product managers and execs can create these definitions and see those definitions taking shape. Security, obviously we have to protect our data between some of the sensitive data that we have with respect to revenue, can only be viewed by certain people with clearance. We started with security and visualization, like I was mentioning. Salesforce Analytics Cloud was a product we used to visualize our data. While we were dealing with all of this, governance should have been the first step, but I know most of you can relate to a similar notion in your organizations. We had to deal with governance. There were too many questions that could be channeled by just reusing, and governance was the way to just connect all of that together to make sure we have the data quality and SLAs and so on and so forth. And after we built all of this, and this is the kind of a 30,000 view of the platform itself, and as you can see, we get data from two broad places: the log sources, that is the thousands of nodes that are there running Salesforce Cloud. We get log files from there through Kafka, and we also get the cloud metrics and cloud profile data from the Salesforce objects through our warehouse into Hadoop. And the stack we started using mainly pure MapReduce jobs, Pig and Hive jobs, and now venturing into Spark. And we have different layers of these jobs that run at different grain, and all of these jobs together will have given us the capabilities of log processing and flow engine that Prashant will talk in a bit in more detail, and data profiling. We're doing some efficient things in data profiling, and we have written pretty much all the MapReduce components in a custom way to be able to profile efficiently. The web app, and one thing I want to highlight on top of this is, if you look at all of this platform, processing is great. We have code reusability. The most important thing is, how do you publish your data sets, your insights, in a multi-grain fashion, and also provide the ability to create cubes so that you can do further analysis. Every time when there's a new question, we don't want to go back and scan through the logs and reprocess everything. So the idea of the last two steps is to just do that. So the way we have done it is, every time when someone adds a new type of question, either it is opportunities or tasks, it creates the underlying metrics, and we publish those data sets in various grain. And now analysts or product managers, they can drill down and deep dive into any level of those data sets. In addition to that, there are specific needs for a product manager who could be, I just want some part of this data to be rolled up, and this specific grain, and I want this refreshed every day. I want to look at the dashboard. And the notion of the cube is to create that intersection of a grain usage data set and a dimensional data set, and this cube will automatically be refreshed for them to view. Any questions so far? Good. Now I'll let Prashant give a deep dive into the implementation of the platform.
Sure. Thanks, Kamal.
You can see from here.
All right. So before I talk about the technical details about the platform, I want to spend a few minutes talking about two very important concepts. First is, Kamal alluded to that, is features and flows. So features essentially is any user interaction, one event. To give you an example, let's say some person goes to an e-commerce website and does some search. That could be a feature. Uh, let's say another example could be someone just visits that website and clicks on categories or whatever. So features can be of like varying granularity. It could be a very high level feature where someone is just visiting a website versus it could be very specific as in someone doing a specific search on that website. So that's features. The other important concept is flows. So flows is a combination of features or combination of events that a user does during a given session. So the questions generally we get are, how many people use this particular feature? For example, how many people search for a particular thing? Or how many people completed this flow? For example, searching for a product, then going to the category tab, and then going to the actual product link. So those are essentially the two types of questions that we have to answer. And like Kamal mentioned, the grain could be very varying. It could be at a very high level versus very granular. How many people did this on desktop, on a particular browser? It could be very narrow and specific. So that's the background for features and flows. So while building this platform, we had few key goals in mind. First one was scalability. Right now, we get over 100 billion events a day. And in order to handle and process all of these events and calculate features, metrics for all of the features and flows, we really need a scalable platform. Also, scalability is important for features. Initially, when we started, we had about few tens of features, then it grew to hundreds. Now we are in high hundreds, around 500 features. Soon we'll get to 1,000, and it's just going to grow. The number of features, flows, and the events that we have to process every day. So scalability, very critical. The second key goal is flexibility. So flexibility can be divided into two parts. So we have about 1,000 different log schemas that our platform needs to handle. So each log schema is different from the other, and our platform should be able to handle all of them in a similar fashion. Tomorrow, if there is a schema evolution, you get a new log record type, we should be able to handle it. So that's the flexibility required for input. For output, I've mentioned this before, but we need to let users create features at different levels. It could be very specific. It could be a very specific action, like saving a file, or it could be very generic, like going to visiting a certain website. Also important is, I mentioned we have 1,000 different log record types, and the schemas are different. So one interesting problem that we have to deal with is, in some log schema, let's say a user ID, the key could be user_ID, whereas in a other log record type, it could be user ID without the underscore. So when people create features, they should be able to specify, okay, if I'm creating feature for this log record type, I want to use this value, versus if I'm creating for some other log schema, I want to use the corresponding value, and all of them should go to one field. That's kind of a way we normalize our data across the 1,000 log schemas that we have. The next critical feature for us is, as a data engineering team, data quality is top of mind. We have to ensure that we know and catch any discrepancies within our data. For this, we need to have a framework which can literally profile terabytes of data every day and tell us if something looks off. So that is another key requirement for this framework. And the last one is self-service. So in one of Kamal's slides, he showed the customers, our customers. So our customers are various product teams. The approach that they would come to us for each question, and we would give them specific reports for each of their questions, is simply not scalable. So we need to have a way to provide them this data so that they can get answers to most of their questions by themselves. So we use Analytics Cloud for this. All right, any questions so far? Okay. Next slide. Okay. So now we talked about requirements. Now let's talk about what are the key building blocks for this framework. So the first one is we need to compute features and flows. For this, we have a process called log processing engine. It's essentially, I'll get into the details in the next slide, all the technical details, but it's essentially, it lets people, any product manager or anyone in the company declaratively define features. Again, going back to my previous example, they should be able to map their features according to different log lines and be able to normalize their data. And the third one is do data cleansing. They can actually inject code. Like if someone is super technical, they could even inject Java code in the ETL, and we would execute it on the fly when we compute these features. So the third one, especially, it's very popular. We see that being used by a lot of people where they inject custom code into our system, and it just gets executed on the fly. The next component is the data profiler. So this, I'm going to talk about data profiler in detail as well, but data profiler is essentially, we have this terabytes of data. We want to understand the distribution of the values for each column. How many nulls do we have? Do we have some data which really looks odd for, let's say, a column where you expect the string to be of certain length? Is it 10 times that length or whatever? Essentially, any discrepancies in data, we would find using the data profiling and monitoring tool. The next is web app. Kamal already talked about it. It's one place where product managers or analysts can go and enter their features and do entire feature lifecycle management. They would enter, okay, I want to track this particular feature in our product. These are the conditions, and this would be the feature ID, and these are the columns that I want to grab, and that's it. They're good to go. And our automation, which is the next component of this framework, it will ensure that right from people creating features to their data appearing in Wave, which is Analytics Cloud, data appearing there is fully automated. So it's very powerful for someone to just go and create features and directly see the data in Wave in a few days. So that's a very powerful idea. So in the next slide, I'm going to talk about the log processing engine, and the next one would be data profiler. So up until now, I've been talking about features. So here's a concrete example of what a feature might look like. Let's say the first column in this, the input to this log processing engine are essentially all the log usage logs plus the feature definitions. So app logs, like I said, hundreds of billions of events, thousands of different log schemas. We are familiar with that. The next is feature definition. So here we have a concrete example where someone says, okay, if the log record type equals X and event equals some create event and some conditions, that would be feature one. So few things to note in this example are, the first column would be sort of the where clause, which is the definition of the feature. What part of the log line, if a particular log line satisfies a particular condition mentioned in that file, it is counted towards that feature. And there could be three, and after that, the first is the where clause, and all the fields after that are columns, which would be available in the output table.
I just want to add one thing to it. So one of the interesting problems we had to solve with this framework is Salesforce, as you know, has been successfully doing this for 15 years. They had 50 releases on the cloud. Imagine over 15 years, 50 releases, they had, what, 1,390 schemas.
Yeah.
And these features, people should be able to say, okay, if there is a log type that was defined 10 years ago to a log type that is now, but both mean the same thing, they should be able to declaratively define that, okay, under the covers, it'll be a huge, long, regular expression that would say, either you qualify that, or another expression, or in between, and I want you to also use some data normalization techniques that rec ID, record ID, record underscore, they're all the same. All of this complexity, we should be able to define that in that feature. We picked some examples for obvious security reasons, but you get the idea.
Yeah, thank you. So I was talking about the types of columns. So there are three types of columns. Essentially, people can define static string, like feature ID that I have here. If you place anything in double quotes, that's a feature ID. If you can plug in variables, like in this case, page is a variable. You can also plug in code, where you can say, in this example, take the event and convert it into uppercase. So there are two very key aspects of this framework. First is we take all of these feature definitions, which are actually text, and convert them into code and run them as code. And the another key aspect is we read data only once and compute all the features. So we look at one log record type and figure out which features or which bucket does that log line qualify for. So that way we don't have to read the data over and over again. We can compute all the features or flows just in one pass. We get the input in form of text. We convert that into Groovy code, and using Java scripting, we execute that on the fly. And it is extensible to any table. So the table number of columns in the output could be different. It doesn't matter. It's very generic. Any questions on this slide? No? Cool. So the next slide, I'll talk about the data profiler. So we looked at we looked at some of the profiling tools out there, but we couldn't find a tool which works for our scale, so we developed one. So the data profiler that we have, it's a native MapReduce job. Essentially, what we want to figure out is, it worked, okay, let me back up. This data profiler actually works on any given Hive table. So there is absolutely no configuration required in terms of how to use this. You give it any Hive table, and it will give you the following metrics. It will give you, for each column type, how many total records were there, what was the minimum length of if it's a string, what was the minimum length, maximum, average, number of nulls, number of distinct values, median, 99th percentile, top n values, and everything.
Yeah, and I think again, another complexity with this was features or flows, which is basically what type of user actions happen in our cloud. Those change over time, and some we may see metrics changing for the right reasons, because people may have a new feature, new version of the same feature that is being adopted really well, and sometimes it's a red flag, right?
Yeah.
The approach we took was, given the data sets that we have, this profiler should be able to tell, okay, how are they deviating? If a particular metric is deviating more than a certain threshold, we would want it to be alerted. And doing that at scale, that is 600 plus features. Each feature has a bunch of regular expressions and case statements and so on and so forth. And doing that at 100 billion events and hundreds of terabytes of data sets, that was the interesting problem.
Yep.
Sorry.
No, thank you. That was good. So I'll talk a bit about the implementation of this data profiler. So it's a multi-stage native MapReduce job. And first stage, what you do is you look at each column, the values in each column, and compute their frequency. That's pretty straightforward. It's just like a word count job. In the next phase, stage 2, it gets interesting. So what we do is we use the secondary sort of Hadoop to to actually sort all the values for a given column in the order of their length or the actual value. So in that way, when the values come to the reducer, we can easily figure out, okay, what is the median, what is the max, and everything. So we all have everything in one place. And we don't do the sorting in memory at the reducer side, because at this scale, we would just get out of memory errors on the reducer side, and it's just inefficient. So the beauty of this is you can do this using secondary sort of MapReduce, secondary sort from MapReduce. So that is one interesting problem. And once we have all of this data in this table, we have a monitoring and alerting framework which emails us or alerts us in case the data looks off. All right, so now I'll hand it over to Kamal to go over the overall architecture and scale.
All right, thanks, Prashant. So any questions so far, guys? I think a few things that I want you to take away is, if this was a problem to solve for a brand new organization, our job would have been like 1/10 of what we did. Just being able to fit to the 50 releases, 1,000 plus, 1,391 to be exact, schemas, and being able to profile all of these data sets at scale, those were the ones that took more time and took some time to make it work this way. And once we got all of that, I alluded to this a little bit, but without publishing the data sets at different grain and without the concept of cubes, it was really hard for us to scale the self-service part of it. We had all the machinery, but every question needed an engineer to create something, a very specific data set. And the last two steps knocked it out of the park, where product managers can define those cubes by themselves and drill through at any grain that they want. So that's most of the improvements that we have done. Any questions, any interest areas? And the profiler part that Prashant talked about, so we had, 2-3 versions of it, and we had to smoke test it to make sure it can scale, because we didn't want profiling itself to take more resources, right? We want the data processing to have all of those resources. We use several of the underlying, yes, go ahead.
Yeah, one question I have is this platform available to Salesforce customers to analyze their data?
Not yet, not yet. This is very new. It's been a year since we started working on it from ground up, but eventually, definitely, there are several conversations that are happening, and we will be providing these kind of offerings in a SOQL fashion, Salesforce Object Query Language fashion, to our customers as well. Thank you for the question. Yes, ma'am.
How are you using this process
To realize? Growth hacking, excellent question. So ultimately, if you look at the use case, it is growth hacking, right? So most of the times, what we have realized is by having the data at that grain, people are now able to, product managers are now able to say, okay, this is the profile of the customers that we need to focus on. And these are the customers. One of the examples I can give is we used some of this platform to solve a very interesting problem. There was a product roadmap that was designed by product managers to say, okay, this is how we're going to release our Lightning experience. I don't know if you're familiar with Salesforce Lightning experience. It's one of the recent innovations that came out of Salesforce. And Lightning experience will touch all areas of the product. And the product roadmap was designed to cover one area at a time, right? And we took, using this data, we were able to show that the most efficient way of applying Lightning experience would be somewhat different if we use the data, because that's what people were using. For example, if you know that 80% of your companies can create end-to-end flows using these 15 features, that is helpful, right? They can focus on those 15 features to create the highest adoption. Does it make sense? Some of those. I think basically the idea was right from the event level, a user click to at a high grain metric, as in what is my MAU for a product. Product managers being able to traverse at any grain has given them that data to be able to act in their roadmaps and the features that they need to focus on. Now, that was the key about this.
There's a question at the back.
Great question. So Salesforce Analytics Cloud is the visualization side of the house. And the way it works is, I have been in this field for a while. I don't know of any other product that can do some of the things that Wave does. It can, you can put hundreds of millions of data set of 100 million plus rows, and you will still be able to slice and dice and create dashboards like that. So they use a concept called search by analytics. Under the covers, we have built search indices that are BI friendly, so to speak. So the way our integration works is from Hadoop, once the data is processed and we create the data sets and cubes, part of the specification, we push them into Wave. They are just like an upload to Wave, upload to any web service. And once it is in Wave, there are predefined lenses, or people can create their own lenses and run this at scale. So for example, if someone were to use Tableau and stuff like that, scaling that beyond a few million rows is quite painful, right? Wave can scale for hundreds of millions of rows.
All right.
And it is mobile first. You can have all of your dashboards right in your mobile phone. Really pretty dashboards. All right. Here are some numbers that we wanted to just highlight. We get hundreds of billions of events, and as companies growing and as people are logging more and more, we have been growing at a pretty fast pace. Last time I looked at it, the log files itself were growing more than 30% year over year. We have 600 plus, 6,000 plus jobs that are in our cluster to do all of this. And all of this is automated end to end. And the number of log record types, this is the 1391 I was mentioning, a lot of schemas. And each schema has a vast number of fields. So the number of fields per schema itself would be in thousands. So that's the scale to shoot on. Thank you. Any other questions?
All right.
All right, guys. Thank you
Thank
very
you.
much. Have a great conference.